We are going to continue with the tutorial about augmented metrics. Okay, so let's do the example of the tutorial. Okay, so here is the question. The question says, solve the following linear system of equations using augmented metrics. Okay, solve the following system of equations using augmented metrics. Okay, so I'm sure we have yeah, let's show it. So we have x. Okay, we have already worked with this system of equation. I'm sure you remember. Okay, so x plus 2y plus z plus w equals to 3, but this time we are going to use its augmented matrix version. Okay, so we have 2x minus 2y plus z minus w equals to 10. We have minus x plus 4y minus z plus 2w equals to 14. This is minus 10 if you recall. Okay, and then the last one is x plus 2y plus w equals 4. So let's check if you recall this system of equations we have previously. Solved it. Okay, but this time we are going to use the augmented matrix version. And of course we should arrive at the same solution. Okay, otherwise it won't work, or no need for augmented matrix. So now let's start. Step number 1. What you have to do is to write it in its augmented matrix form. So the augmented matrix form is okay, so let me write augmented matrix form is, so here is the augmented matrix form. So we have if you recall, on the left hand side we have the coefficients, so we have minus 1, 2, 1, 1, and then on the right hand side we have the constants. Okay, we have 2 here, so if you take the second row, the coefficients of the variables, so we have 2 is the coefficient of the x, minus 2 is the coefficient of the y, 1 is the coefficient of z, and minus 1 is the coefficient of w, and equals to minus 10. Minus 1 for the third row, we have minus 1, 4, minus 1, 2 equals to 14, and the last row we have 1 plus 2, 0 for z, and 1 for w equals to 4. So how you perform Gauss's method on the augmented matrix. So let me rewrite the augmented matrix and perform Gauss's method, and I'm going to fly through it quickly. Okay, 1, 2, 1, 1, 3, 2, minus 2, 1, minus 1, minus 10, minus 1, 4, minus 1, 2, 14, and 1, 2, 0, 1 equals to 4. Okay, so let's go with the first. So what we have to do is I want to use minus 1 in the first row, first column, to eliminate the 2 in the second row, second column, the minus 1 in the third row, first column, and then okay, so I'm going to use -1 to eliminate everything below it. Then afterward I'm going to use the lead, so this is going to be the leading entry. -1 is the leading entry of the first row. Okay, so I'm going to use the -1 to eliminate all the entries below -1. So I'm going to eliminate 2, -1, and 1. Is that okay? So what I have to do is for the to eliminate the 2 here, I have 2 row 1 plus row 2. Okay, should give me, so we have -1, 1, sorry, 2, 1, 1, and 3 here. So we have 0 here, so 4, so we have 2, 3, and 1, and -4. Okay, so we have 2, 4 minus 2 is 2, and 2 plus 1 is 3, and 2 minus 1 is 1, and 6 minus 10 is 4. Okay, and then for the third row, I'm going to multiply the first row by -1. So minus row 1 plus row 3 should give me, okay, 0, 2, -1. Okay, so this is going to be -2. Okay, and 1 here, because um, we have here -1 plus 1 plus 2, -1 plus 2 is 1, and here we will have -3 plus 14 is 11. Is that okay? So let's continue. The third row, I'm going to do each computation next. Okay, so we have 4 here. So what I need to do here is row 1 plus row 2. So we have row 1 plus row 2. Okay, will give us -1, 2, 1, 1, and here we have 3. Okay, so we have 0, 2, 3, 1, -4, 0, 2, -2, 1, 11, and so row 1, so we are here. Okay, row 1 plus row 2, row 4, sorry, row 1 plus row 4 is 0, and row 1 plus row 4, that's going to be 4. Okay, that's going to be 1, and that's going to be 2. Okay, so 4, 1, 2, and that plus that is 7. Okay, now let's continue with now we are going to use the leading entry in the second row to eliminate the entries below it. So I'm going to do here minus row 2 plus row 3. It should give us, I hope I will have enough space, 2, 1, 1. Okay, good, I can make it. 3, so 0, 2, 3, 1, -4. I need to keep it, and then I have 0, so -2 plus 2 is 0, -3, -2 is -5, and 0, and 15. Here for the fourth row, I'm going to do -2 row 2 plus row 4. So -2 row 2 plus, so we have 0 here, 0, -2 row 2. So we have -6 plus 1 is -5. Okay, -2 plus 2 is 0, and plus 8. 8 plus 7 is 15. Okay, so the next step is to use the -5 here, which is the leading entry in the third row, to eliminate the entry below it. Okay, so we have I'm going to do minus row 3, okay, plus row 4, -1, 2, 1, 1. Okay, So we have 0, 2, 3, 1, minus 4, 0, 0, minus 5, 0, and 15, and 0, 0. So minus by minus 5 is 5. So 5 minus 5 plus 5 minus 5 is 0. And minus 0 plus 0 is 0. And minus 15 plus 15 is 0. Okay, so this is going to be the echelon form matrix. But we are asked to solve it. So here, if you recall the next step, first of all, we have to see which type of solution set do we have. Is it no solution, unique solution, or infinitely many solutions? Many solutions. Here we arrive at the echelon form. So here this is the echelon form. Okay, and we have no contradictory equation. Therefore, we have a solution, at least one or infinitely many solutions. But if you see here, we have a row where one of the variables is not leading. So we have a total of 4 variables, and we have a total of 3 leading variables. We have a total of 3 leading entries, minus 1, 2, and minus 5. That means there is at least one variable that is not leading. Therefore, we have infinitely many solutions. And how do we write the solution set? So if I can go a space here, how do we interpret this? So this is x, y, z, w. So here that means we pick the third row. So let me write it clearly. We have if you pick the third row, okay, what we have minus 5. Okay, minus 5 z equals to 15. That means z equals to minus 3, as we have previously seen. If you pick the second row, okay, of the echelon form, of course, second row, what do we have? We have here 2x plus, sorry, 2y, I meant to say. We have 2y plus 3z plus w equals to minus 4. And if you perform the calculations and you sub in the minus 3 for the z, and you write it, you parameterize it in terms of w. Okay, so that means we have 2y equals 4 minus 3z minus w. If you do all the substitutions and the computations, you will see that y equals to 5 over 2 minus w over 2. Okay, and then the first row, how do we rewrite? The first row from the matrix, we have minus x, okay, plus 2y plus z, okay, the coefficients here, and plus w equals to 3. That means if you, okay, x is going to be, x is going to be written as minus 3 plus 2y plus z plus w. That means if you, after all the substitutions, you will see that x equals to minus 1. So we can use augmented matrix to solve the system of equations. So far, the solution set is not in its final form. We have just arrived at its description, okay, and very soon we will see how do you write it using vectors notation. Okay, so I think I have to stop here, and I will see you in the next video for the lecture. Okay, thanks.